Thank you very much. And thank you for inviting me to this impressive conference. Very nice to be here. And I know some of the people here as well. My name is Gunar Friborg. I'm from a Danish MOLIO company that works with knowledge sharing and digital information and methods. I've been a standardization expert for many years now. I work both in CEN and ISO standardization committees and IEC standardization committees. I'm going to talk about classification today. There's actually a lot of information and very limited time. I will talk in headlines, and you're very welcome to maybe study the details later on. Let's go. I will try to get through these 6 bullet points about background, development of the classification, how it was made, how the principles were, how it's implemented in software and in the Danish construction sector. And I'll talk also a little at the end about the CCIC collaboration and future perspectives. So let's move on. Background, research scope. The background, actually we tried 3 times to do a classification for BIM. Starting the first one in 1997, we have had digital practice for quite many years in Denmark, and you can see the second attempt was actually the one that made the ICT, the BIM requirements in Denmark in 2007. So we have had official BIM requirements since 2007. But first, with the project in 2011 to 14, the Coneco project, later the classification that was made was later to become the CCI. And when we did that, we were told very much by the Danish ministry, the Danish Construction Agency, now please look out for international standards and digital development also in other sectors and domains. Try to learn, so please no national perspective. So that was one of the important tasks. But we also asked, of course, all the BIM users. We already had a lot of BIM use going on since 2006-07. So what do you need? And they said, this should incorporate the whole built environment. You should focus on the digital practice by BIM use. We don't want to look in analog stuff. We want to look it up as we do on the internet. It should focus on how does it improve the collaboration, the collaborative uses, and how will we make it suitable for project and information coordination across software platforms, across parties, and please make it standardized. We want to use it not only in Denmark, but also working with international partners or going abroad for export. And the vision, we try to encompass it in this picture, a little small island in the middle of the Great Belt in Denmark, where bridges, roads, highways, landscape, buildings, everything come together. And we said we need to use it through all the phases of a construction asset through the entire life cycle, and it should be used by all parties. And why was that so important? Because it actually showed by some research we made that we were going to revise the ISO 12006-2 classification standard that Martin talked about earlier on. And we thought it was not good enough for actually supporting what we wanted to do, and we wanted to know what do other countries do. So we made a global survey on how classification was used in many countries and how they used it with BIM. And the result was very poor. It was not very much used with BIM because it was very analogically based in catalogs, big catalogs, and also it was very much only for consultants and maybe surveyors, but contractors and maintenance people, and they didn't use it very much. So we also had a group working in the International Construction Information Society, and we had a group discussion with 14, 15 people coming from all over the world on how do you solve these problems? How do we work with classification in the future? The report, if you look at the presentation in the PDF, you can click on the report front page and you can read it. It's only 30 pages, but maybe it's a little bit for experts, so now you're warned. The purpose for BIM classification and identification, in short, is that we wanted to secure all information in an information structure. If that sounds familiar, it's because actually that's a terminology used in the ISO 19650. And it should also be able to integrate information across diagrams, building models, data templates, whatever platform you worked on, and be a part of the information model, all ISO 19650 standards. Also, we had the focus of how to create breakdown structures. That was actually before ISO 19650 started to mention these things. So what are the objects, for instance, in part or type of structures? And part of structures, of course, is very interesting because everything we do when we do geometrical modeling is actually putting objects together for a construction entity. So all are part of that building, for instance, or that infrastructure object. Specifically, it should be able to identify objects by their characteristics, grouping them. That's very normal for classification. And having standardized definitions. If you look across the world, all the construction classification you can find besides CCI actually have no defined object classes. That makes it very difficult also to map them and also to look how they map against, for instance, IFC entities. So we thought that was important. And identification, that's everything about, and very often classification is used for that purpose. And that's very difficult because classification itself actually is not very clear for identification. It's something about referencing objects being part of a structure, being a sequence number, or having a specific functionality in the building, like being the product, or having a function, or being at a certain location, or being a certain type. So, and what did when we made that survey, we found out that very many of the classification system we found, the numbers here are entries for doors, and only for doors. And in very well-known worldwide classification systems. And that's not very suitable, and our users said, oh, no, if we're going to change, every time we change a bit about a door, we have to change classification code. That's not going to work. That will be a lot of administrative work, and it's not stable all through the life cycle. So please make a generic classification for object classes in BIM, where we can use related and standardized properties. The problem at that time, and also when we got out with the system, was there was no standardized properties. There were only very few of them. Now there is beginning to be a lot. That's very nice. So the 23386 and 387 standard series from CEN and ISO actually describe how to use standardized properties in a specific way. So that really supports what CCI was made for. The development of the CCI classification, we needed to look at how to do it with terminology. We tried first ourselves and found out we were actually very poor at that. But they had a Dan-term terminology group in universities in Denmark that said, oh, we need to help you with this because you're on the wrong track, friends. So they helped us, and they said, okay, what CCI has to do is that we have a generic classification. The object has one object class preferred term. A door is a door. We have only one door. It will remain a door all through its life cycle, but it will have a lot of properties. They can be changing all through the shift of phases and may be improved in the maintenance situation, but it's still a door. And we know it's a door because it has a class definition. It's a space access object for upright passage by persons. And that's very nice. Even if you put it out in the field and you go through it, that's actually what it does for you, right? So, and then it has a classification code. So the combination of the classification code and the definition actually is the thing that defines the door. The main concept, or preferred term as it's also called, is door. And the entrance, exit, door opening are typical synonyms used in many languages, and you could probably find more. And then there are all the materials and things around the door that goes into the door and actually are properties. So let them be properties, not being a part of the classification code, because then we have to change it all the time. So it ended up in classification tables, and you can see here the preferred terms, and you can see to the left of them you can see the definition and the classification code, and to the right we listed all the terms, synonyms, examples, types we could find. They were put into the 81346 Part 2 standard at that time because they had a very clear definition on how to do that. And it was used in many other domains or sectors and industries throughout the world. So the development following this is that we started out with the CCS, that was what we called it at that time. We used these three standards to the left, and we used the two terminology standards, and we used building smart IFC entities, saying we have to be as close as possible to these principles and standards. And then Sweden joined, and then we revised the ISO 12006 Part 2 for classification standard, and we revised also, we developed a new 81346 Part 12 with technical systems and functional systems and the principles for using this classification. We revised the Part 2, and a Part 10 was made for power plant, came out last year, and the Part 1 about the identification principles were also revised. And now at the moment it's been proposed to make a Part 14 for manufacturing systems and a Part 50 for processes. And why has that happened? That happened because when we did that for construction, other industries said, wow, that's even much better than what we already use the standards for. So big companies like Airbus, Tetra Pak, Vestas Windmills, Norwegian Hydro and others went into it and said, wow, we can use this. This actually is the answer to our digitalization efforts being a basis for this. So what it does is it consists of systems. It's very much system thinking. We have functional systems. We have technical systems that are within functional systems, and we have components within technical systems. So the technical systems is very much the solution. Components is typically what you work with in calculation and on the construction side and for maintenance. So we can handle it on very different levels. So it's 1, 2, and 3 letter code, so it's very easy to identify. This is a bit complicated, but it does tell you that there are 4 aspects. You can even create more aspects if you want to. For instance, product aspect, seeing it as a product to a functional requirement, function aspect. If you don't have a reference model like a geometrical model, you can have use allocation aspect, and you can use the type aspect to do what traditional classification does, make types. So here's an example. This is classification. The 1-letter code are the functional, the 2-letter code are the technical systems, and the 3-letter code are examples of object classes for components. And at the other side, and it takes too long to go through this, there is the syntax structure for how to actually use it for identification. The nice word is reference designation system. This is the syntax, and that means it's programmable. So software can actually program this and read this and show the information in a user interface using this in the background. This was made for digital purposes. What we found out was for other projects in digitalization was that it was very difficult to actually, very many software and digital projects failed because the language beneath was not clear, it was not well identified, it was not well established. So having a common terminology across disciplines, for instance in construction, creating some classification, taxonomy, establishing principles and methods how to communicate it, standardized, and creating meaningful user interface was actually the ones that made it. And it's very comparable to being a musician. If you are able to read the notation, if you're able to understand the science, you know what to do, even if you actually haven't played that piece of music before. And it's also, for digitalization, very much a prerequisite. If you want digital communication, you need to have put it on a solid ground. And also, we've experienced from the development of new standards like linked data, and even we've seen examples for intelligent use of AI. With AI, you need to have that kind of well-defined terminology and language if you really have to be will be successful. Is it used and implemented? Yes. Let's see, CCI classes have corresponding IFC elements. IFC does not cover all the object classes in CCI. Well, maybe never, because it's very much focused on the modeling, but maybe it will. Because a lot of things that you find in specification, in diagrams, and in calculation and other stuff, maybe you can't find that in the model. And not always anyway. When we made the CCI properties for how to embed the CCI codes into to the software tools, we made it the same way as IFC properties was made, and could put it into property sets using the same naming conventions. We have tried to put CCI classification being a part of Building Smart Data Dictionary. It was used by Leon Berlin in a demonstration project at a conference we made, and it was very successful. And now the collaboration parties in CCIC have decided that with 6 or 7 languages, we all want to have the CCI classification put into the Building Smart Data Dictionary, so you would find it with grids, the grids there. So today it's implemented in more than 20 software tools for BIM users in Denmark. This is not mandatory to use in Denmark, so other purpose classification systems also exist there. CCS, which it was called in the beginning, it was used within MOLIO tools to structure information. We had different access possibilities like APIs, navigator databases, so software people could download it into their software. It has been used in the Danish projects for buildings since 2014, and now it's used in more than 50% of all public funded projects being required to be used, because it's also very suitable for maintenance and operation. And the updated version of this now includes also infrastructure classes. We, for instance, made, this is just for Revit, I think we also made it for Tekla and ArchiCAD, shared parameter files, so it was easy to use. You can see there it is with CCS, but it also exists with CCI. And now it's taking into infrastructure, BIM development. The Scandinavian countries and Czech, Poland, and Slovakia has decided also to focus on and Lithuania has focused on how can we use this in infrastructure. There was made a very nice report about that with testing a classification system, and in very big projects in Denmark, both for the Defense Ministry but also for the BIM Info Group in Denmark, it is now used in test projects. So I will end up with just saying, to organize a work around a common classification system like this, that is very much based on a lot of standards. In between the revision of standards, you want, of course, to maybe change something, or you want to add new classes, or you want to add more examples or types. So how do you do that? The model, the conceptual model from ISO 12062, where all the blue spots are where we have classification tables in CCI, and all the green ones are something we work with. these 7 countries actually work together with. We have a trusted board for decision making and a technical committee for practical work and coordination. And within the periods of revision time for standards, the standards behind, we can propose to each other, is this the right object classes to have for instance, new infrastructure objects we identify. And then maybe a further perspective. Very often when I hear about the digital twin, I only see the geometrical model. That's a pity because information structure, not all information can be referenced in the geometrical model. We don't do geometrical models as detailed as, for instance, companies like Airbus does. But even Airbus that does even the tiniest screw is into their models, they still need to have an information structure where they can put all the information that's been added all the time, also for maintenance and operation. So what we actually can do with the way we can use CCI for configuration, we can make, for instance, spatial structure, location view information. We can have, for mechanical engineering, the functional view, specification, all the information attached to all the object classes we have there, or for assembly and manufacturing, what we call the product view, and for operations type of view, we can also make those structures. It only depends on how you build your information structure system around a construction entity, whether it's a building, a piece of infrastructure, or any other thing. An airplane, for instance, 70% of what goes into an airplane actually also exists as objects in a building. So we think we can support also the development of the digital twin with this. Thank you very much.